Okay, so just while we have our attendees joining us, I just want to say welcome to everyone to today's webinar. My name is Laura Egan O'Brien. I'm the marketing manager for the college here in UCD. Today is the second of our UCD College of Engineering and Architecture virtual talk round event series. And we'll be hearing today from Professor Peter Kennedy, who is the head of our School of Electrical Electronic Engineering. We'll also be hearing from Professor Madeleine Lowery, who is the program director for our Masters in Biomedical Engineering. They're going to be giving us an overview of the programs available in that particular school. And also at the end of the session, you'll have an opportunity to ask us any questions that you might have around applying to us or studying with us and career opportunities, that kind of thing. For the Q&A part of the event, we'll also be joined by my colleague Katie O'Neill, who is a senior marketing manager for the college, which some of you may have been in contact with if you've been making applications to us, or a scholarship application to us also. Some housekeeping notes just before we get started. For the best viewing experience today, if you want to just make sure that you're in speaker view mode, which if you're not already, you can toggle in the top right hand corner of your screen. And also when you're asking us questions, you use the Q&A button, which is in the control panel at the bottom of your screen. Throughout the event, type us any questions that you have, but we'll actually maybe leave answering them towards the end of the event in case the academics cover any of your queries that you have in their presentation. And just the lastly thing, just to let you know that we will be recording the event today, so I'll share that recording with you afterwards as well, and I'll follow up with you with some links to resources that you might find useful after also. So I think we have a good amount of our registered attendees with us online now, so we'll get started. And first up is Professor Peter Kennedy, who, as I said, is the head of our School of Electrical Electronic Engineering. So Peter, if you want to start us off.
Okay, hi. Welcome to everybody present. Can you all see? Yes, we hope so. Okay, so I'm Peter Kennedy. I'm Professor of Microelectronic Engineering and head of the School of Electrical Electronic Engineering in UCD. We have traditional undergraduate electrical engineering programs. We've about 400 undergraduate students based in Dublin, and then we've about another, through a joint venture with Beijing University of Technology, we've about another 400 based in Beijing. In terms of the programs we're talking about today, these are master's programs. These are taught master's programs, and we have two types of taught master's programs. One's called the Master of Engineering, and the Master of Engineering is a 2-year program that sits on top of a traditional 3-year undergraduate degree. I'll talk about 3 of these programs. One is the ME, the Master of Engineering in Electrical Power Engineering. The second one is the ME in Electronic and Computer Engineering. And then the third one is the ME in Optical Engineering. So these are 2-year programs with a work placement. We also have a 1-year program called the Master of Engineering Science. And the Master of Engineering Science is a 1-year taught add-on to a traditional 4-year Bachelor of Engineering degree. So let me talk first about the ME programs. In Ireland, we make a distinction between what we call electrical engineering and electronic engineering. So electrical engineering tends to refer to the heavy electrical side of things, power generation, distribution, electrical machines, these kind of things. Electronic, on the other hand, is related to information processing, communications, and control. So the first program, the ME in Electrical Power Engineering, this, as I said, is to do with generation of electrical power, transmission of electrical power, distribution, and now it's becoming more popular to store electrical power and to use it in novel applications, electric vehicles, and also things like electric heating in homes. So this is an area where there is a huge demand worldwide for power engineers. People who work in power systems, who work in things like renewable energy, which is becoming more important, and people who work in applications of electrical machines, such as autonomous vehicles or electrical transportation systems. Also, as I said, electrical storage is becoming more important as there are more renewables. Ireland as a country has a very particular electrical grid. It's separate from Europe, or has been separate from Europe. There's no AC connection to Europe. And because of that, and because we have a large amount of renewable energy, particularly wind, in our system, the country has developed world-leading expertise in integrating renewables into an electricity grid. So it's a particular area of expertise in Ireland, particular area of expertise in our university. And if you learn from the people here, it's great experience to take to the rest of the world as others are dealing with the issues of integrating renewables into the system. So that's the Electrical Power Engineering program, Master of Electrical Power Engineering, a 2-year program. In the first year, the first semester of the first year, you take some courses, and then in the second semester, you go on an industrial work placement. So you work with a company in the electrical power industry. That company, that's typically a paid internship, and it lasts for a period of 6 to 8 months. The second year of the program then is coursework, and there is a research project with that as well. And the research project will be something that suits you and your supervisor, and again, will be in the area of power engineering. So power engineering, as I said, is about using electricity to do work. That's how we consider power engineering. The second program I want to mention is the ME, Master of Engineering, in Electronic and Computer Engineering. So here, instead of using electricity to do work, we use electricity to process information. That's things like electronic circuits and systems, signal processing, communications, and control. Again, this is an area of activity where there is huge demand for engineers worldwide. Some companies in Ireland are leaders in the field in this area. A lot of the American multinationals have a presence here. So students during their work placement in this program will work for companies like Analog Devices, Xilinx, Cypress Semiconductor, and others. Graduates from this program are also qualified in signal processing, and many of them go into consultancy afterwards, or go into financial services. So electronic and computer engineering is, students studying this will learn things like signal processing, circuit design. Because of the computer emphasis, we'll do things like data analytics, programming, and data science. So somebody who's interested in a future in data science will also get a good qualification in this area. The structure, again, it's a 2-year program. The first semester, coursework. The second semester, industrial placement, lasting 6 to 8 months. And then the second year, coursework with a research project. Again, these research projects will be things like circuits, communications, signal processing, control, data science, analytics, and so on. That's the ME in Electronic and Computer Engineering. The third one I want to mention is the ME in Optical Engineering. Now, this is a newer program, and instead of using electricity to process information, optical engineering is concerned with using light to process information. So the main applications for people who graduate in optical engineering are in things like communications. A lot of the communications today, long distance communications, not by satellite, but is over optical fibers. That is a very important area. The other area that's becoming increasingly important is imaging. And Madeleine Lowery will speak later about biomedical engineering, one of the major growth areas for optical engineering is in the area of imaging technologies. So those imaging technologies are being used in things like sensors for detecting chemicals, detecting biological substances, also sensing things that were sensed electrically. Many of them are being sensed optically these days. So optical engineering is a newer program and a growing area. There is a demand for optical engineers in many smaller companies in niche applications, mainly related to sensors. But there is also a great demand in the area of imaging in some of the larger companies that make imaging technology. So once again, this is a 2-year program. First semester coursework. This coursework will have an emphasis on photonic technologies, so things like lasers, light-emitting diodes, and also processing of light using things like lenses. So a person who has an interest in physics, it would be attractive to them. The second semester is a work placement of 6 to 8 months. And then in the second year, once again, there's coursework plus a research project in the area of optical engineering. They're the 3 ME programs. They are 2-year degrees, and they sit on top of a 3-year engineering qualification. So if you have a 3-year engineering qualification, this is the capstone to that. Alternatively, we have the Master of Engineering Science. This is a 1-year program, strictly it's 12 months, and it sits on top of a traditional 4-year engineering degree, such as one we get from India, China, or the United States. The 4-year, the MNGSC does not have a work placement, but it does have coursework, 2 semesters of coursework, and a research project. The research project runs over the summer months at the end of the program. So this program, again, you can work in a number of different areas. They will probably be in the areas of circuit design, signal processing, communications, control, and things like data analytics, data science. So that's the MNGSC, Electronic and Computer Engineering. Students who study on this program are entitled afterwards to work in Ireland, and many end up working with a lot of multinational companies and also Irish companies based in this country, or that's where they tend to go. So these programs, the ME programs, the ME program has a class size of about 40 students per year, and the MNGSC program has a class size of about 25 students per year. So if you join one of these programs, that's the size of the group, the class size you'll be working with. The ME programs most of the Irish students will follow the ME program. We have a lot of international students in both the ME and the MNGSC programs coming from a range of countries. So we welcome people from both Ireland and from across the world to these programs.
Great, thank you very much for your time, Peter. That was really interesting. I hope our attendees found it valuable as well. So next up, we're going to introduce Professor Madeleine Lowery, and she's going to talk us through the ME in Biomedical Engineering, as she's the program director for that particular course.
Thank you very much, Laura, and welcome to everybody. We're delighted that you can join us today. So I'd like to talk a little bit about the Masters in Biomedical Engineering that we offer at UCD. So my own background is in electronic engineering, and I'm part of the School of Electrical and Electronic Engineering. But here in UCD, we offer a Masters of Biomedical Engineering that is jointly delivered between the School of Electrical and Electronic Engineering and the School of Mechanical and Materials Engineering. And we also work very closely with colleagues in the School of Medicine and also in chemical engineering and other schools within the College of Life Science or Health Sciences to deliver this program. For many of you, maybe I'll start off by saying many of you might be familiar with biomedical engineering, but for those of you maybe who are less familiar with it, I can start off by giving a little introduction to it. So what is biomedical engineering? Well, we often think of it as the application of engineering principles to try to understand, modify or control the human body. And we use engineering in this way to develop new methods for treating different types of conditions and in order to help improve quality of life or health, working closely with the healthcare sector. It is rooted in a foundation in electronic and mechanical engineering primarily, certainly for the course that we offer here. And then as we move towards the Masters in Biomedical Engineering, we build on those foundations that you have in order to deliver interdisciplinary modules that sit at the intersection between engineering and medicine. Similar to the ME programs that Peter just mentioned, the ME in Biomedical Engineering is a 2-year program. Most of our students come either through our own 3-year program, or they come in externally from either a 3 or 4-year program with a background in biomedical engineering, electronic engineering, or mechanical engineering. The program that we deliver, as I mentioned, is offered jointly between our 2 schools with some additional modules as well, delivered by colleagues in health sciences. The program delivers, you have a selection of modules that you would take within that first year of in the first semester of the first year of the Masters, and then students typically go on work placement from January through to the end of the summer, till the end of July or August. Most of our students are placed within the medical device industry, which is very strong here in Ireland. And we also have a number of students that get placements in the hospitals. So for example, we usually have at least 1 or 2 students in the National Rehabilitation Hospital, which is based in Dún Laoghaire, close to UCD. And students in the past have also been based in the Mater and St. Vincent's Hospital on placements there as well. But most of them tend to work in the medical devices and medical technologies industry. To give you an idea about applications of biomedical engineering, often people think straight away maybe about prosthetics. That might be one of the things that comes to mind very quickly. But really it's a very, very diverse area and spans everything from artificial limbs and gait analysis through to development of rehabilitation robotics, imaging such as MR imaging, CT imaging, building and designing devices such as pacemakers, electrical stimulation systems for integrating with the nervous system, the very important ventilators and CPAP machines that we're hearing about a lot at the moment. They're all designed by biomedical engineers. It covers everything from neuroprostheses, cochlear implants, through to biomaterials as well, and how we design those devices that will interact with the body and what special considerations we need to make there. Also, of course, biomedical signals and data. So now with the huge developments in ICT and miniaturization of devices and the ability to transfer large amounts of data, there are great challenges there in the area of data analytics, wearable sensing. How do we integrate this information and extract useful information from it? So it's a very, very interesting area. I mentioned that most of our students go on work placements to a wide range of companies within the medical technologies industry here. And that's where most of our students will go afterwards as well into employment. So the medical technologies industry is particularly strong in Ireland. We have over 40,000 people are employed by the medical technologies industry, and 9 out of the top 10 international medical device companies are based here in Ireland. So it is an area of real strength within the country, and it offers many opportunities for our students. Our graduates are also in demand, and our students on placement also. So all of our students were placed this year by December, which was really great. It's an area, as I said, that's very rich in opportunities, both for working in it and also research opportunities later on also. Maybe if I give you an idea of some of the subjects that you might study if you did take this program, in the first year of the ME in Biomedical Engineering, you would first of all take a basic course in basic medical sciences for engineers, which is taught by our colleagues in medicine. You would also take a course in biomaterials, biomechanics, medical device design, and then you'd have a number of options as well where you could choose from biomedical engineering subjects or subjects at an advanced level that are offered in electronic engineering, mechanical engineering, depending on your own area of expertise and your own area of interest. When you return in the second year, then you also have an opportunity to take subjects such as bioimaging, biosignals, experimental design and statistics, neural engineering, rehabilitation engineering, biomechanics of cells and tissues, and cell and tissue biomechanics. So there are a wide range of subjects there, and there's an opportunity for students to tailor their options depending on their own background and on their own expertise. In total on our programs, we have about 160 students on our undergraduate program, and about 40 students in each year of our master's program. In the final year of the master's, students also do a research project where they're supervised by academic staff from across the two schools, and those projects can take on a wide range of areas. So everything from analysis of signals, designing devices, biomaterials projects, biomechanics projects, so a wide range, and there's a good opportunity for you to align your project with your own background and your area of interest also. So I think that's everything I have on the to say on the ME in biomedical engineering, but I'd be very happy to take questions if people have them afterwards.
Great, thank you very much, Madeleine, for that. So that's both for academics have given us an overview of their programs. I think we'll move on to the Q&A section of our event today. So if anyone has any questions, if you want to use the chat button at the bottom to just write us a question, and we're more than happy to answer them for you. While we're waiting, I might just ask Katie just to have a quick word on maybe the current situation around COVID-19, because I know some of our students are quite worried about that, or some of our applicants are quite worried about that. And it was a question we got on our webinar on Tuesday. So Katie, if you maybe want to answer that just around what we're hoping to let our students know about, and what they where they can go to get more questions answered.
Yeah, so the university itself has compiled a very comprehensive list of questions relating to COVID-19. Of particular interest might be how we're currently handling the situation with our own students who are currently studying either at an undergraduate or a postgraduate level. And also we have a range of questions that may be on your minds as you have applications with us, or if you're considering studying with us. So what I will do is I will post in the Q&A in just a moment the link to that. And I would definitely advise that you save that, because that has been updated on a weekly, if not daily basis. So that's the most accurate and up-to-date information you can get relating to COVID-19 from the university. So I'll pop that in there now.
Great. Thank you very much, Katie. And I'll also follow up after this event with the recording, obviously, but some links, and I'll use the link that Katie's going to put in the chat also, in case you don't make a note of it. So some questions coming in now. One of them is for the ME in electronic and computer engineering. How many modules and kind of the variety of modules that you can take per semester for that particular course? Peter,
okay, so
that one?
I have that one. I'll answer it. Okay, so for the ME in computer engineering, our program is organized on the basis of ECTS credits. Okay, so that's a European system of credits. It means that every semester you take 30 credits. Now, modules are typically courses are worth 5 credits. Therefore, you take 6 credits, 6 modules in a semester.
Great. And then another question coming in is just around companies, maybe that you're aware of that students have gone to in the area of biosignals.
Biosignals specifically, we have, I'm thinking the big medical device companies. We have the students in, well, Medtronic, Boston Scientific, Dupuis. We also do have students in smaller companies who are interested in biosignals. So one would be BMO and Galway, who make electrical stimulation devices. There's another company here based in Dublin, which is data analytics around healthcare in general, which is Optimum. Fire One is a small startup company which is looking at biosignals as well, and looking at different imaging techniques there. So there's a variety. Probably in biosignals it tends to be smaller companies, SMEs and startup companies.
Great. And Madeleine, just sticking with you as well, do you find that students who are coming from an electronic engineering background adapt quite well to doing the biomedical engineering degree?
We do. We always have a number of students who come either from a pure electronic background or a pure mechanical background, and they adapt very well. What happens for, say, if you're coming from an electronic background, one or two of the subjects might be a little more challenging than they would be for somebody with a mechanical background, and vice versa. if somebody's coming in with a mechanical background. So the one that probably tends to be a little bit more challenging is biomaterials. I think that's one that people can find a little bit difficult, but with a little bit of reading around it and some guidance from the module coordinator, there's never any problems there.
Great. And I think this is from one of our current students. It's just asking for, obviously, students who are doing the integrated ME program with us, if they're choosing their stream in third year, is there options to change their mind or pick a different option then when they're going at the start of fourth year?
I'd say absolutely yes. I mean, we accept that students, when they see modules, they mightn't like it or might have thought it was something else. And of course, we respond and we allow students to change streams. Great.
And Katie, I might just follow up with you on this one in particular. It's a student who has made an application for our ME in Biomedical Engineering, but obviously due to the situation around COVID-19, they can't complete their language test probably as they would have.
Helpful if I unmute myself. So that's a good question, and we've had that question from a number of our applicants who are concerned because they can't complete the conditions of their English language requirement as they had intended. The university has responded by allowing Duolingo testing. So also we got some very good news today as well that this is also being considered around visas as well. So what I'll do is I will post in the Zoom webinar chat the exact details of what you need to do, but Duolingo is being accepted alternative in which to satisfy the conditions of English language requirement while we face this current situation. But I'll pop the exact details in the webinar chat now.
And then Madeleine, just as well, microelectronics and signals and systems are different programs, sometimes in other universities and other degree options, but in UCD we have it included as one single ME program. Are you able to speak to that or the kind of rationale behind that?
That's probably Peter on electronics, isn't it? It's microelectronics and signals and systems.
Okay, so let me answer that one. The microelectronics and signals and systems. Okay, in UCD we tend to be towards the circuits and systems side of the house rather than very much devices. So in other places, microelectronics sometimes means the devices and the manufacture of devices. We are more towards the design end of things. And in terms of design, traditional circuit design at the transistor level now requires knowledge of signals and systems and architectures at a higher level. And therefore, you can't really separate those two. And that's why for us, they're together. You can't just do transistor level design anymore without understanding how the system works. So we see the two as an integrated whole.
Okay, great, thank you. And just in relation to the electronic and computer programs, both the ME and the MNGSC, if a student was trying to choose between one or the other, is there any advantages or disadvantages, obviously, except for the placement opportunity in the 2-year, that a student maybe is thinking between one or the other?
Okay, I had a 4-year undergraduate program from UCD. I graduated with BE Electronics, and I did a 2-year master's. The reason I did the 2-year master's was because I wanted a large research project. So I guess one difference between the MHSC and the ME, the ME has the work placement. The ME has a bigger, sorry, the MHSC has a bigger research project. So really it's a personal choice. Again, I did a master's because I wanted to take courses that I couldn't do in other places. So the coursework is a very important part for me, but it's a personal choice. Do you want a range of courses? Do you want a course emphasis over a shorter, more intense period? Or would you like to take more time and have a work placement? It's really personal choice.
And Madeleine, just around the biomedical engineering course, how heavy is the emphasis on mechanical engineering? And obviously from a student who's not coming from a mechanical engineering background, will they progress okay, or how will they get on?
Yeah, so our experience has been that students do very well on it. If they're coming from, once they have a good either electronic or mechanical or biomedical engineering degree, they do fine. By the time you're at master's level, we're really looking at interdisciplinary subjects. So we're assuming a certain basic knowledge, but we're looking at subjects that are right at the interface. So if you're coming from an electronic engineering background, you'll probably tailor your options that you're choosing a little bit more towards signals and systems and electronics, at the electronic side of biomedical engineering and bioelectronics. So you won't have to take, very hardcore mechanical engineering subjects in that case, and it'll be vice versa from someone coming from the other side. You would have to take biomechanics, biomaterials, and they're the only two core ones, but really every biomedical engineer needs them, because even if you're dealing with signals and systems, you need to understand how those devices interact with tissue around them in terms of biomaterials. And also if we're dealing with, for example, the signals that the human body generates as it moves, we need to understand the mechanics underpinning that. So it's at that level that it's needed, but students do very well on it.
Great. And then also in relation to students who maybe are doing an MNGSE or don't have any work experience, who are going into careers after their degree, do you find students get on okay with that? Peter, for yourself, if students who are doing the one-year program and don't get the work experience, or Madeleine, students who do the ME program and only have work experience as far as our placement that we do offer, getting jobs afterwards.
I'll just say for the MNGSC Electronic and Computer Engineering, if you go online and you look at the brochure we have for that, there's a little 2-page brochure, but there's a profile of a student who took the program, and it's actually an Indian student who worked afterwards, is now working with Intel. So there is a huge demand for people in the fields of electronic computer engineering, also optical engineering and power systems. Particularly in power systems, we just can't produce enough graduates. So I think whatever program you pick, if you succeed in the program, you will absolutely have no problem getting a job in the area.
I would agree exactly with Peter for our program also. There's a very, very big demand for biomedical engineering graduates. We don't have a one-year MSc at the moment in biomedical engineering, but we do have students who graduate with the bachelor's degree who wouldn't have work placement, and they all have no difficulty in securing employment in the industry.
Great. And then for our MNGSE options, do you find that the workload is more intense because it is just a one-year program versus our 2-year programs?
Okay, again, our own undergraduate students do 60 credits in a 9-month period. So they'll do 2 semesters of coursework at 30 credits apiece. The master's, the MNGSC has those 2 30 credits, and then a summer project that's worth another 30. So yes, you're working for longer in the sense that you're working for 12 months instead of 9, but in terms of the total, in terms of the pace, I reckon the pace is about the same. You're just working for longer doing the project over the summer period.
Great. And Madeleine, for the Biomed Masters, if students are obviously coming from either an electronic or a mechanical engineering background, are they able to stick with that stream? I mean, if they're doing from a mechanical point of view, they'll stick with the mechanical side, and they don't have to do electronics and vice versa. No,
they would have to do so similar. If you're coming in from the mechanical side, you would take, as again, they're interdisciplinary modules really. So there's no pure electronic modules that they would take, but they might often be students who take neural engineering, which for example is a course that I teach, or rehabilitation, which is taught by electronic engineering and has a strong underpinning of electronics underneath that, or electrical engineering principles, but they're designed so they're accessible to students coming from that background. And the sort of fundamentals that they would have in that area, maybe coming from their undergraduate degree, would be sufficient there. And they can also choose their options. So they could tailor their options so they're more on their, if they're particularly interested in materials, they could tailor there, or in dynamics, they could choose options at the advanced level in mechanical engineering to allow them to take those.
Great.
In parallel.
And then also for students who are maybe wanting to supplement their degree with other certificate options, does UCD offer or recommend any supplemental certificates that students would get, or maybe CPD that they could get as far as along with their degree, or maybe even post-degree?
Okay, so we encourage all our students to learn as much as they can. Now, both the ME and the MHSC are busy programs. I notice this question is related to a particular CPD options. We have a program in development, which if funded, it should be rolling out probably next year. But that program will be flexible to allow people in working in industry to take particular modules. This is particularly addressing the needs of the microelectronics industry in Ireland. There's a shortage of RF circuit designers, also power electronic circuit designers, mixed signal circuit designers, and design and verification engineers. So we are designing a flexible program that will allow people based in industry to engage on a part-time basis with that program. We don't have it just yet, but that's coming.
Great. And then also we've got another question around students who are interested maybe the more robotics side, which of our master's programs would be the best suited for that particular interest?
I would recommend electronic and computer engineering, but maybe Madeleine can say something about how robotics is being applied in biomedical at the moment.
It probably depends on what area of robotics they're most interested in. So we do have, robotics is quite a large component of biomedical engineering as well. So rehabilitation robotics, which would be exoskeletons, prosthetics essentially are robotics, and a lot of biomedical engineering as well feeds into the design of robotics in terms of trying to replicate some of human function. But it depends. If they're interested in we would be maybe looking towards applications, whereas if you're interested in the electronics behind it and the control, that'll be more electronics. And then if you're interested in the mechanical side, you could be looking at mechanical. So I'd say which side of it you're most interested in. I don't know, Peter, would you agree on?
Yeah,
Aspects and everything. Yeah.
It's down to personal choice. Again, if you like do you like the automation side of things? Do you like smart vehicles? Do you like, as Madeleine said, prosthetics? It's down to your own interests.
Mm-hmm.
Great. And Peter, would that be similar for the ME in electronic engineering? If a student is maybe not wanting to do subjects around signals, but maybe have more interest in microelectronics and computers, can they steer the degree that way also?
Okay, again, I would encourage you to look at the descriptions online. We have some core modules. You must take those, and they're to give, basically the reason for giving the core modules is these are modules, these are basic courses that we believe will be important no matter what you do afterwards in your career. So you must take those. But then there's great flexibility in terms of options you can take, and the options will typically be chosen by the student based on their personal interest and the kind of research project or work placement they might like to do.
Great. And then is it possible for students who are undertaking the research project to do that in collaboration with industry, or maybe as a lead on from their internship placement?
Okay, again, most of the faculty in the school have connections to industry. We work with industry, we have research projects with industry. Typically those projects will be for PhD students, but we'll often be doing a little bit of background work or exploratory work, and we can do that with the master's students. So typically what we'll do is we'll try to engage a master's student in a project that we might like to develop with a company. The company then sees the student sees the company, and if it works out, we might develop that further into a PhD, or at least give the student some exposure to a company that might have an interest in what they're doing.
I could say something as well, maybe Laura, on students coming out of work placement who have ideas for projects. So when we interact with the students on their work placement, one of the things we ask them to keep in mind is if they would like to propose a project based on the work that they've done in collaboration with the company. So we always have a number of students who do that every year. And just to note, it's not a continuation necessarily as such, because there's a very clear line drawn between the work done on the work placement and the start of the research project. But it might be work that are ideas that they've had from their time working in the company. So there's normally a number of students that do that in all the programs, I think.
Great. Madeleine, there's just a question around maybe potential students who are having difficulties or struggling with the biomedical engineering course, and is there, what supports are available to students, and maybe do students end up dropping out? If you could speak to that.
In terms of dropping out, we've never had students drop out of the master's program that I know of. They tend to be very good students that come in. Their class size is reasonably small. It's, I suppose, at around 40 students. So we tend to know the students, you know, by the time they're at the end of their second year. The program directors, it's myself and my colleague Ona Carroll, who's in mechanical engineering. So students will typically come to one of us if they have issues, and then if it's anything more serious, then we can help refer them on to University Services or on to Colleen Blaney, who's our student advisor in engineering.
Great. And then is it possible for our students who are looking to maybe supplement their degree with doing teaching assistant roles at UCD, and is that something that your faculty, you know, support students to do?
Currently, PhD students are the only ones who are engaged in TA roles. But we are exploring what we might do in the future as if we have a need for more people. So it's one of the things we're considering, but as of today, it's only PhD students who are involved.
And UCD Engineering in particular has a great reputation for spin-outs and starting companies and things like that. And for students who are maybe engaged in that process, what kind of supports are available, or, you know, have we in the past had students who go and start up companies while they're doing their degree?
Again, I'll refer you to the brochure. If you look at the brochure for the MHSC Electronic and Computer Engineering, you'll see that one of the modules that a student can take is called Enterprise Innovation and Entrepreneurship. So we encourage students to do this. It's a little bit difficult to be both starting a company and doing a degree at the same time. So we might give you the background work or the background training, and then maybe that's something you do after you graduate. But certainly there are startup companies, and in terms of some of the faculty members have startups and have links to those startups, and there might be a way through a project to engage.
Great. And Madeleine, do you have examples of some of the research that's going on in UCD Engineering, or some of the projects that students have worked on related to the electronic side of biomed?
Electronics, sure. But I was going to, when you started to ask the question, I was going to say, if people want to have a look at the UCD webpage, there's 2 news bulletins there that feature 2 of our graduates on the ME Biomedical Engineering program. One is Andrew Dixon, who's involved in printing visors for the hospitals around in Dublin. So he's working with iForm at the moment. And another is a student, Colin Keogh, who's involved with the open source ventilator project. And so they're both biomedical engineering graduates. In electronic engineering, if I speak of my own research interest, it's in the area of neural engineering. So we're interested in understanding how the nervous system controls human movement mostly. We're interested in looking at the signals that muscles generate, how they change in disease states, and how you can interact with them through the use of different types of interventions, such as electrical stimulation or quantifying movement with different therapies. We've an interest in deep brain stimulation, or at the moment we have a project looking at respiration to see if you can do home monitoring of patients using signals recorded on the phone. I have colleagues, Giacomo Severini is interested in rehabilitation robotics and control of movement also. And Giacomo is working closely with the National Rehabilitation Hospital locally. Simon Kelly is involved in cognitive neuroscience. So Simon is really interested in understanding how we make decisions and how these competing signals work within the human brain, how we can monitor signals from the brain and extract information from that. And Stephen Redmond is interested in wearable sensing and technologies there, and also developing robotics and robotic sensors that can emulate the sense of touch, or the manner in which humans can sense touch. But many colleagues throughout electronic engineering are interested in applications in the area of biomedical engineering. So right through from imaging, as Peter mentioned, John Healy and Sean Sheridan are interested in photonic applications and imaging. Colleagues are interested in developing wearable sensors, in signal processing, signal analysis methods that come with that as well. So there are many people as well involved in the different applications of it.
Great. We've just got a couple more questions just related to, I suppose, students who are maybe concerned about the COVID-19 situation as far as our intake in September goes. So for those students, I'd say, I know Katie has put in the chat some of the links to our frequently asked questions around COVID-19. As I'm sure most of our attendees can appreciate, that it is a fluid situation at the moment, so things are constantly changing. We are operating that on the basis that we will be operating as normal in September. Just keep an eye on those frequently asked questions, because they'll be updated regularly, so you'll know what's going on, and you'll also be communicated with if you're making applications with us on an ongoing basis as well. Just to have that in your mind. And then we have another couple of questions, just one in relation to progression into master's level. Obviously, entry requirements are also listed on our graduate studies website. Each individual program has specific entry requirements around a GPA of 2.8 to progress into master's. Katie, maybe if you could field that question. Is there a GPA of 2.8 to progress into the master's?
Is this an internal or an external student out of interest?
I'd say it's an internal, just because it's a progressing into the master's. I'd say it's an internal student.
Okay, so if that student wants to email me directly rather than discussing their GPA live on a webinar, that would be super. My email address, I'm going to type it up here again, and if they email me, I will get back to them this afternoon. We can just their particular case.
Great, thank you, Katie.
For external students, just so that they're aware, it's generally the equivalent of a 2-1, which would be a GPA of about 3.08 out of 4.2 if you're applying from another university.
Great, thank you. And then just speaking to obviously students who are going to be coming out in maybe 2 years' time with one of our ME programs, and what the economy is going to be looking like, and maybe job opportunities at that stage, if you want to talk about what the industry is like at the moment.
Okay, I'll just speak for the power business and for the electronics business. So the power industry, the traditional power industry has, many of the engineers in that are older. A lot of them are retiring, and therefore there is a huge need for engineers to go into power systems. The other thing that has changed in power systems is it's becoming increasingly important to integrate renewable energy into systems, and storage is becoming important. And these are things that even the older engineers were not familiar with. So there's a new generation of engineers required to bring those skills into that industry. There's also the issue of the dynamics of power systems. When there are a lot of renewables in the systems, they're much more complex than they were before. And again, people with lots of control expertise and dynamics are required. So the power industry globally requires more engineers than any of us produces. There's just a global shortage, and that's not going to change. The electronics industry, again, you look around anywhere in the world, what is happening? There is more and more electronics going into everything. There is more signal processing everywhere. There is more data analytics, data processing. This will not end for a long, long time. So the employment prospects have been very strong, and through whatever crashes there have been, the prospects and the growth after them have always been excellent. So I wouldn't worry about what things are going to be like in 2 years' time. I expect that they will be very strong.
Mm-hmm. I can add something if you like, Laura, on the biomedical engineering or the medical technologies sector. There's a very good website that the Irish Medical Technologies Association has, so students might find that interesting. It's irishmedtechassociation.ie. Just to give you a sense, Ireland is emerging. It's a real strength here in Ireland, and Ireland is emerging as one of 5 global hubs for medical devices internationally. I mentioned that we have 9 of the top 10 medical device companies here, but on top of that, you have a lot of indigenous industry, and over 60% of the companies are indigenous companies also. And it's employing about 40,000 people at the moment, with over 12 billion in exports. So it really is a huge area and a huge part of the economy. So, well, we don't know what happens in the future, but I think that's it's clear that there is a demand for our graduates, and we'd expect that to continue.
Great, thank you very much. We just had one more question around scholarships, but I might get Katie, if that student wants to follow up with Katie just by email afterwards, that would be great.
I do, sorry, just looking at the question there, it's straightforward. Yes, if you receive a scholarship as an undergraduate, or even, for example, if you're an international student coming into us for a 2-year program, The question was, would the scholarship hold over to the following year? And the answer is yes, once you meet the minimum requirements for a rollover, which is 3.08 out of 4.2. So if you're coming in first year of a 2-year master's, it will continue into your second year once you maintain your minimum GPA. The answer is also yes to that student's specific query in terms of progressing from an undergrad to a taught grad once the minimum GPA is maintained.
Great. Thank you very much, Katie. I think that's most of the questions that we've had. If we don't have any more questions coming in, we might end the webinar there. I just want to say thank you to everyone who has participated today, anyone who's asked us questions. Thank you to Madeleine and Peter and Katie for participating with us also. To anyone who's watching, I would say that we will follow up with all our students afterwards. I'll send a recording of the webinar today to them, and any questions that we haven't got a chance to answer today, you can follow up with myself or Katie, and I'll send you a link to some of our resources around COVID-19 so you can keep up to date with that. And thank you very much for participating with us today. It was great. And maybe some of you will join us for one of our other sessions coming up next week as well. Thank you.
Thanks very much, Lauren.
Thank you.
Bye-bye.